Today we have a real quick video on a small job we took on doing some machine work on this 3-cylinder Yanmar, specifically a 3TNV84. Our customer brought us the short block in the cylinder head after experiencing overheating of the engine and a blown head gasket. After at least one attempt of replacing the head gasket and seeing a failure in the same spot on the center cylinder, they determined that the deck of the block needed to be resurfaced. With some layout fluid on the deck surface, the block was fixtured on our boring and surfacing mill, and a beginning cut of 1/1000th of an inch was started. For reference for those of you who don't typically work in dimensions that small, 1/1000th of an inch is roughly 1/3 of the diameter of the average human hair. With the initial 1/1000 cut, it's obvious that our cutter did not touch the entire surface of the deck. From our point of view, the cutter cleaned most of the right edge, all of the front edge, and most of the left edge, as well as near the head bolts on the back side. If this had been a 5/1000 cut and it looked this way, I would be very concerned that we weren't set up true, but in this case it can be attributed to a combination of warpage from overheating, as well as a slight difference between my setup and the last time this block was decked. By 2/1000 total off the deck, we see that the cutter touched the entire deck surface, excluding the areas where the head gasket seals, especially around the center cylinder. The low spots around the cylinder definitely would contribute to a head gasket failure. At 3.5/1000, the surface is starting to look better, but still not perfect. With one more cut and a total of about 4/1000ths of an inch off the deck surface of this block, we're confident that we will have a flat surface and a nice surface finish to give a head gasket the best odds of sealing. We're planning on honing the cylinders of this block, but while it's set up on the machine, I went ahead and machined a bit of a chamfer to take off the sharp top edge of the cylinders to aid in installing the piston rings later on. After overheating multiple times, the cylinder walls and the pistons had a small amount of scuffing, so after discussing with the customer, we opted to get a set of 0.25mm oversized pistons for the rebuild, which puts our minimum final bore size at 3.3169 inches when we do the conversion, since our micrometers and bore gauges read in inch sizes. Since we have just shy of 0.1000ths of an inch to take out in the cylinder hone, we'll start with our coarse diamond roughing stones, which are great for removing larger amounts of material very quickly. Real quick, I want to say thank you to all of our fans. If you're new here, be sure to hit that subscribe button, and maybe even head over to our website and cop a sticker. After just a couple of light strokes in the hone, we can see the areas at the top of the cylinder which are either worn larger and or warped where the hone hasn't touched yet. Our goal after honing the cylinders will be to have cylinders that are on size with a consistent surface finish for the entire cylinder, top to bottom. When you're only going 0.1000ths oversize or less, it's kind of a toss-up between boring the cylinders and then honing, or simply using the hone like this to remove all of the material. If you're going to go any more than 0.1000ths oversize, it's more efficient to bore the cylinders to within 3 to 5/1000ths of finished size before moving into the hone. While I'm sure this looks simple from your living room couch, I can assure you that the cylinder hone is one of the more complicated machines in the machine shop to master. All of your work has led up to this point, and you generally have a very small amount of material to work with to make sure that you hit your tolerance for proper piston to wall clearance, make sure that the cylinders are round and straight from top to bottom, and that doesn't even begin to mention getting the proper surface finish for proper ring sealing. After all the cylinders are roughed out, we're going to start the process of finishing out the cylinders, beginning with our coarse stone abrasive, which you can see leaves a slightly smoother surface here on the center cylinder compared with the diamond on the outer cylinders. The rough stone is used to bring the cylinders out very near to final size, before a stone with a much finer grit is used to finish our cylinders to the proper diameter. With all the cylinders finished, this little block should be good to go for another life cycle, so we're going to get it completely cleaned up and ready for assembly. As we all should know, when your engine is overheated and blown a head gasket, you're really only fixing half of the issue if you only surface either the head or the deck of the block. This head also had some issues with the valve sealing, so we'll be touching up the seats, but before that we'll be resurfacing the head to help negate any future head gasket issues. Sure enough, the surface of this head closely mirrored the surface of the engine block, and in fact, it actually ended up being almost twice as bad as the block, requiring 0.007 of an inch to fully achieve a flat surface. This no doubt attributed to the head gasket issues. The valve guides were actually in decent shape, and we opted to get new valves for the engine and touch up the old valve seats here on the valve seat machine. While worn, the seats didn't look bad enough to warrant the extra expense of being replaced. As long as we can cut the seats to get a good concentric and aligned seating face, while still remaining within the specified limits of valve depth relative to the surface of the head, we'll be in good shape. As usual, our goal is to remove as little material as possible while still producing a quality seat. With all of the intake seats cut, we can check our valve recession with our new valves to verify that they're all within the allowable spec of 12 thousandths to 20 thousandths below the surface of the head. They are leaning towards the lower side of the specification, which on a diesel like this means a lower compression ratio, but we have also raised the compression by surfacing the block, so we're comfortable being in this position. The exhaust seats are resurfaced as well, and I know it's difficult to tell on the video, but the exhaust seats machine differently to the intake seats since they're made of a notably harder material to withstand the hotter temperatures that the exhaust valve experiences. The exhaust valve recession spec is the same 12 to 20 thousandths below, and we came in on the deeper side of spec just like the intake seats. While it's always easier to produce a high quality end product when you're replacing every single part of the engine, it's not always necessary and it becomes a balance of cost, time, and quality. In this case, the increased cost and labor time of replacing the seats would only be marginally beneficial as our end result is still within the specified tolerance. But in the end, we've tackled the critical areas of the engine to have good sealing valves, good sealing piston rings, and solid surfaces for a good sealing head gasket, the core reason the engine was here in the first place. Thank you all for watching, and we hope you enjoyed this quick video. Stay tuned for some of the cool jobs coming up, including continued work on the Ford Model A and the 4.2 liter Jaguar. Thanks for watching, and we'll see you in the next one.